Okay, hi everyone. This is our final group project, and our group members are Patrick and Zishan and Ishan. And we chose our group topic as investigating on factors that influences students' final grades. Our goal is to build and evaluate multiple linear regression models to predict the final grades based on academic, demographic, and lifestyle factors, and also analyze which groups of factors most strongly influence performance. And the reason why we chose this topic is that we believe that there is a lot of factors that can influence the academic performance. So we want to understand how these factors work together to influence the student final grades through this project. And by using the regression analysis on the UIC student performance dataset, we'll look at different factors that has the biggest impact on performance. And our goal is to find patterns that can explain why some students perform better than others and highlights which area might be the most important for improving the academic outcomes. And we believe that it has strong practical meanings in our lives. And for my part, I conducted a research question that is how do a student time schedule, that is free time after school, going out with friends, home to school travel time, and weekly study time interact to influence their final academic performance. So I set my null hypothesis as there's no statistically significant relationship between free time after school, going out with friends, home to school travel time, weekly study time, and students' final grades. And to start with the research process, I describe the data first. As you can see that actually the variable of travel time, study time, free time, and go out, they're kind of categorical variables. They set the five levels for each variable. One, two, three, four, five, or just one, two, three, four. Uh, and the level one means they barely spend time on it, and the level four or level five means they spend a lot of time on it. And the distribution of the grade is kind of generally like a normal distribution. And also, we investigate on their pairwise relationship. As you can see that there are a positive relationship between study time and the final grades, time of going out and free time, and time of going out and travel time. And other relationships are all negative. Based on this understanding, we built our initial multiple linear regression model. And we run the regression. The result shows that longer home to school travel time leads to lower final grades, and also more weekly study time leads to higher final grades. And going out with friends more frequently predicts lower final grades. And also, there's no significant relationship between the free time after school and the final grades in this model. Um, and also, you can see that the R square for this model is only 0.073, although it is quite small, but it is not unusual for in this situation because there are a lot of factors contribute to educational performance, and this behavioral predictors is only a small part of it and only can explain small part of the performances results. And then we try to improve our models a little bit. Uh, we start with the multicollinearity detection. We use VIF to detect these issues, and the results shows that the values are all smaller than 5, which means that there's no significant multicollinearity concerns. And also, we draw the residual plots for it, the plots between residuals and fitted values, and also the plots between standardized residuals and fitted values shows that there's no obvious heteroscedasticity in this model because the plots are just distributed randomly along the horizontal line. And the QQ plot shows that the distribution is a normal one, except for its heavy tail, but it is quite normal in the large sample. And also the plots for the residuals and leverage values shows that there are only several influential points. And to detect heteroscedasticity issues, we conduct BP test. The p-value is 0.95, which is greater than 0.05. It means that it shows that there's no significant heteroscedasticity issues in this model. And also to detect the normality of residuals, we conducted the Shapiro test. Although the p-value shows that it is quite small, uh, and which shows that it is actually not a normal distribution, but because this data set is quite a large data set, it has nearly 300 samples. So we also need to look at its QQ plot for residuals. It shows that it is a normal distribution except for the heavy tails. And to detect the outliers, we use the Cook's distance. We found that there are several influential points, but we decided to keep it because they are not highly influential in this model. Also, we conducted the bootstrap to avoid any normality issues in this model, and we show that um, the range of the slopes in this model, that is for travel time, it is around negative 0.2, and for study time slope, it is around 0.25 to 1.1. And for free time, it is between negative 0.3 and to positive 0.3. And for the which is actually not significant in this model. And for the going out with friend time, it is the slope is around 0.70 to 0.05. And also we try to add another quadratic variable term in this model, that is the uh, study time that is the study time, but the model shows that this variable didn't show a significant impact to our final grades. So we try to conduct a F test between the basic model and the quadratic model. It shows that the F value uh, the possibility of the F value is zero point 0.6, which is greater than 0.05. It means that actually there's not a significant differences between these two models. And also the AIC and BIC values tells that the basic model is still better than the quadratic model. So we decided to keep the basic model as it is. So here is the conclusion for our first research question. That is, um, Even though the model has a very slow explanatory power, we still believe that it is a good model because it shows a significant impact between these three relationships. That is, more study time leads to higher grades, and more travel time leads to lower grades. And also, more time going out with my friends leads to lower grades. These conclusions are stable across OLS, Robustic, and also Bootstrap, indicating they're statistically reliable.
So for my research question, I researched about how the students' time, study time, previous failures, and the absences relate to the final grade. The null hypothesis is that none of these variables have significant relationships with the final grades, and the alternative hypothesis is that at least one of those variables have significant relationship with the final grades. So moving on to the data description, um, here we are looking at the basic summary of our data set and how each variable is distributed. The final grade G3 ranges from 0 to 20 in the first graph, with most students scoring between about 10 to 14. The second graph, study time, is mostly concentrated at the lower values, meaning most students only report studying 1 or 2 hours per week. Failures and absences are both highly skewed. Uh, Most students have no failures and relatively few absences, but a small number of students show much higher values. School support is also imbalanced, with only a small portion of students receiving extra help. These patterns give us a good initial understanding of the overall structure of the data before moving on to the deeper analysis. Next, we look at the pairwise relationships. In this slide, you can see the pairwise correlations between all of our predictors and the final grade. The strongest signal comes from failures, which has a clear negative relationship with G3. More failures almost always corresponds to lower grades. Study time has a small but noticeable positive correlation with G3, suggesting that students who study more tend to perform slightly better. Absences in school support, however, show only weak direct correlations with the final grade. Finally, the predictor to predictor correlations are all modest, which is good because it means we don't have major multicollinearity concerns going into our regression model. Next, we look at the MLR model. Um, in this slide, you can see the summary of the results of a multiple regression model. We found three significant predictors of the final grade. Study time has a small but meaningful positive effect. Each level increase is associated with about a 0.37 point increase in G3. Failures is by far the strongest predictor. Every additional past failure lowers the expected final grade by roughly 2.5, 2.4 points. Um, School support also shows a negative effect, likely because it's typically given to students who are already struggling. Absences, however, are not significant once the other variables are controlled for. Overall, the model explains around 19% of the variation in the final grades and highlights failures and study habits are as the most important factors. Next, we look at the multicollinearity detection. Um, we check whether our model meets the key assumptions of linear regression. The VIF values are all very close to 1, which tells us that there is no multicollinearity among the predictors. Looking at the residual plots, the residuals are mostly well behaved and only slight deviations in the tails on the QQ plot. There is also mild heteroscedasticity, shown by the spread increasing at higher fitted values, but it's not severe enough to invalidate the model. Um, Here we can see that in the Brush-Pagan test, um, it shows that the p-value is significant, which means that our model does have some heteroscedasticity, which means that variables of residuals increases slightly as fitted values increase. This matches what we saw earlier in the residual plots. The Shapiro-Wilk test also gives a p-value slightly below 0.05, indicating that there are mild deviations from normality, mostly due to slight heavy tails. However, these issues are common in real-world educational data and are not severe enough to invalidate the model. Next, we look at the Cook's distance values for each observation in the dataset. While a few points stand out as moderately influential, none of them exceed common thresholds for concern, meaning that there is no single student in exert, meaning that there is no single student exerting enough influence to distort the model. Uh, these mild spikes are expected in real educational data sets, especially for students with high absences, unusually low or high final grades, or multiple pass failures. Since none of the points are extreme enough to justify removal, we keep all our observations in the final model. Next, we look at um, the quadratic model. Um, so in this slide, we test whether adding a quadratic term for study time improves our model. The coefficient for the squared term is essentially zero and completely insignificant, with a p-value of 0.998, meaning there is no evidence of a curved or nonlinear relationship. The ANOVA comparison also shows no improvement, and both AIC and BIC actually increase for the quadratic model. This tells us that the added complexity doesn't explain the G3 at all. So the simpler linear model is preferred. And study time's effect on final grades is best understood as a small linear increase rather than a nonlinear pattern. To wrap up, our model explains about 19% of the variation in final grades, which is typically for educational data. Even with modest explanatory power, it reveals um, clear and stable patterns. The strongest predictor by far is past failures. Each additional failure lowers the expected final grade by roughly 2.4 points. Study time also matters, showing a modest but positive effect on the performance. School support is associated with lower grades, which likely reflects the support is given to the students who are already struggling. Finally, absences do not significantly predict G3 once failures and study time are accounted for. Overall, the model highlights the importance of the academic history and consistent study habits in shaping students' outcomes.
Yeah. For the final research question for our group, I would like to talk about how do students' study habits, school and familial engagement, and alcohol consumption interact to influence their final academic performance. The null hypothesis in this case is none of these predictors, basically, which are study time, absences, family support, or daily alcohol use, has a statistically significant effect on G3. And the alternative hypothesis in this case is at least one of them does have a significant effect on G3. Now, to explore the variables that were used in this case, if you can go to the next slide. Uh, Here, before running any of the models, I looked at the distributions of these variables. Here, most of the students reported kind of lower study time, where around 1 to 2-ish hours. Then moving on, there was also low alcohol use, which created like strong peaks in these categories. And absences, on the other hand, were heavily like rightly skewed in this case, where most students miss a very few days, but some miss over 20. And finally, the outcome variable, which is G3, is almost normally shaped, which is centered around a final grade of 11 or 12. I think so understanding these helps us like choose appropriate modeling decisions and like prepare for diagnostics later. Now, if you go to the next slide, here I looked at the pairwise relationships between these different variables. A few interesting patterns that I noticed. One of them was like the study time has a positive relation with G3, which basically means that students who study more tend to earn higher grades. And then also that alcohol use and absences had a positive relationship amongst themselves. And as far as negative relationships are concerned, alcohol use had a negative correlation with the final score, which suggests that heavier drinkers tend to underperform. Also, study time is negatively correlated with both absences and alcohol use, which suggests that students who like study more tend to skip classes less and drink less. I think all of these variables basically tell us how a regression model will develop and help explain which predictors might matter the most. And then as I build the initial linear regression model, you can go to the next slide. Here, our main model predicted that G3 uses using four variables, which is basically study time, absences, family support, and alcohol consumption. And the results showed that the study time is a significant positive predictor, where more weekly study time is associated with higher final grades. And alcohol use is a significant negative predictor, where increased alcohol consumption lowers expected G3. Now, absences and family support in this case were not very significant when we control for the other variables. Even though here R square is just 5.2%, I think with other studies that we refer to, it's typical for this kind of data to have a low R score, where human performance is influenced by many unmeasured factors, which we have not considered in this study. Well, I think so. What matters here are significant predictors are basically consistent, and we can interpret them meaningfully. Now, if you can go to the next slide. Now, this is where we perform some of the diagnostic checks. We evaluated the model assumptions here, where all of the VIF values were mostly around 1, which showed there's no multi-collinearity problems. And the residual plots showed moderate but acceptable deviation, which shows no major violations of linearity or homoscedasticity. And in the BP test, in the next page, yeah. And here for the BP test, we basically showed there's no significant heteroscedasticity here as well, because the score was around normal. And for the Shapiro test, again, there was no significant results that could be found. Finally, I also ran the Cook's distance, which showed a few influential points, but none of them were strong enough to like basically meddle with the model that we created. And because of this, only if also there's one thing to note is that a few points showed some elevated influence, but none of them that exceeded the levels that would actually threaten the model stability. Now, moving on, I also checked for Bootstrap, and these fully align with the regression results. Here, study time remained a reliable positive predictor. Alcohol use remained a reliable negative predictor. Absences and family support consistently showed intervals that include zero, confirming that they do not significantly affect G3. This basically adds robustness and increases our confidence in these conclusions. Now, to test for the quadratic model in the next slide, we just wanted to check if any quadratic term actually made the model better. But in this case, the quadratic term was basically non-significant, and both AIC and BIC scores actually increased. This tells us that the relationship between study time and G3 remains linear, and there's no evidence of like a non-linear effect that could be introduced because of several other factors. So this was basically the project that I made, and the overall performance in conclusion. Study time is the strongest and most meaningful positive predictor of final grades. Uh, the alcohol consumption significantly reduces academic performance, Absences and family support do not significantly predict G3 once we account for like study time and alcohol use. Although this model explains a modest portion of the variation, it still identifies clear, interpretable behavioral patterns that students and educators can act on. Finally, studying more and drinking less are two most consistent behavioral factors associated with better academic outcomes in this data set, according to the study that I performed. Yeah.